Hi everyone. I just want to do a short sound check. I know that this video is going to be a little bit laggy, but it's okay because usually for physics classes we're just doing a webinar. So usually if people have questions to ask, they usually type it out. So I decided to use this way for physics, and then we'll see how it goes lah, for the rest of the subjects. But I will most likely use this for only physics now. Okay, now if you are not aware of what's happening and the reason why everybody is typing their name and their class in the live chat, it's because one of the things that we've been asked to do is to take attendance of students who entered the session. So it would really help me, especially if you're from SM Lok Yok, to please make sure that you write your name and your class uh, for so that I can record down who entered the class and who this one lah. Okay, whether you're from S1, S2, or S3, please make sure that you write your attendance so that I can note it down. Secondly, if you are a guest here from another school, because I know that there are some people from other schools that have expressed interest to join this class, just introduce yourself. Um, just state your name and which school you're from. I know that there's one school in Terengganu. Some of you may be from that school. Definitely welcome. Okay, welcome to our webinar. I hope that you can follow what we are about to learn from today's session. Okay, secondly, if you have any questions, if you have any questions to ask, then you type it out in the live chat. Okay, you type the questions out in your live chat, and then only at the end of the class. Okay, only at the end of the class, I will scroll through everybody's this one, and if there's any questions, then I will answer them. Okay, so don't be afraid to type out your questions. Just if you have any questions, if you have something that you want me to explain again, ask me. I'm just ask it in the live chat session, and then I will highlight the question, and then I will answer the question then. Okay. So yes. So just so that you know, all questions lah. Okay, all questions will be answered only at the end of the live session. I mean, yeah, only at the end of the session. Once we have finished learning, then only we will. I will answer all the questions lah. Okay. So for today, what we're going to do is we're going to start on a new chapter. Okay, and the chapter is called chapter 5, which is radioactivity. Okay, and then I'm going to share this screen with you so that we can start learning lah. Okay, so our chapter here today is radioactivity. Okay, and it's always interesting that whenever we talk about radioactivity, we always have this picture of the nuclear reactor or something to do like this lah. Okay, but interestingly enough, there is no such facility in our own country because our previous Prime Minister, Dr. Mahathir, has decided that Malaysia is not ready for such a facility. Okay, we are saying no to using nuclear technology to power our electricity lah. Okay, so maybe at this point, some of you are asking, why are we learning chapter 5? Sorry, I know it's chapter 10 because it's chapter 10 in the whole syllabus, but it's chapter 5 in Form 5. Why do we go from chapter 2 then skip to chapter 5? The reason is because we felt that chapter 5 is a little bit easier to learn offline and also non-face-to-face method. It requires less explanation. It just requires a lot more learning on your own part lah. Okay, whereas chapter 3 and chapter 4 requires a lot more hands-on, so we decided to see whether we can wait until the RMO is over, if it's ever going to be over, to see if we can only cover chapter 3 and chapter 4 then. Okay, so bear with us. We're going to go into chapter 5. There's a little bit of things that you may need to carry forward with you from chapter 3, but don't worry about it. Okay, I think it's still possible for us to learn chapter 5 without really knowing what's happening in chapter 3 lah. Okay, so chapter 5 or chapter 10 in the whole syllabus is called radioactivity. It is most commonly associated with nuclear bombs and things that are supposed to be exciting to students, but actually it's far from it. Like, it's more than just nuclear bombs and all that kind of immature stuff. It's actually a brand new way of looking, at how things work. Okay, so just to give you a concept map, what's happening. Okay, so um, this is the whole chapter in itself. Okay, we're going to start off with this. Okay, the nucleus of an atom. Okay, we're going to start off with this, the nucleus of an atom, and then this part is a little bit more chemistry, and actually you have learned this before, which is why I'm also going to go a little bit into radioactive decay. But I'm going to skip this first part because I want to cover this in the next lesson. I'm going to go into this part. Okay, characteristics of radioactivity emission, okay, and ionizing power and penetrating power. Setakat itu lah. Okay, then on the next class on Wednesday, we will talk about radioactive detectors, half-life, and then this one, the isotopes application. And then only we will talk about this very big part next week or after the RMO. Okay, depending on how we do this week. Okay, so let's start. We're going to go into the nucleus of an atom. In order for us to understand how radioactivity works, we really need to understand the composition of a nucleus of an atom. Okay, that's very normal. Okay, so, and this one actually has been covered in chemistry. It's covered in the first part in chemistry a long time ago, okay, when you were in Form 4. Okay, so we're going to just roughly go through this. Everybody knows this, okay, that all matter, okay, is made up of the small particles. At your level, the smallest particle that you know is known as the atom. Of course, when you go into higher level physics, there's other stuff that is even smaller than atoms. Okay, so each atom has a very small and very dense core called the nucleus over here. Okay, and most of the mass of the atom is contained in the nucleus. Okay, the heavy chunk is in the nucleus itself. And then we find that the electrons move in orbits around the nucleus. Okay, so this one is, kalau dalam bahasa Melayu kita panggil ini petala. Okay, by English we call it orbits. And we find that the electrons are all moved in orbits, okay, around the nucleus. Much like our solar system. Okay, the middle of it is the sun, which is the heaviest of them all. And then the rest of the planets just, orbit around the sun. Okay, so our solar system also has that same model. Okay, so there are a lot of empty spaces within the atom. Okay, so a nucleus consists of a number of protons and neutrons. So in the center over here is all just protons and neutrons. Okay, and proton has a positive unit positive charge, and the neutron is an uncharged particle of about the same mass as the proton. Okay, almost the same mass. So imagine if proton is mass m and then neutron is mass m, two combined together with 2m. That's why the nucleus of the atom is very heavy, because the protons and the neutrons are already very heavy itself. When you combine them together, it becomes even more heavier. Okay, so it's very heavy, it's very dense, okay, and it contains protons and neutrons. Okay, now an atom is neutral because it contains an equal number of negatively charged electrons. So the net charge is 0. So for example, in this case, let's assume that the red color is a proton and the black color is the electron. So if there are 3 red color protons, okay, means it's 3 positive 3 the charge. Okay, and then the black color, the electrons are negative 3. So because the same number of protons and electrons, therefore we say that this atom is a neutral atom. Okay, what if I'm going to change this? What if the blue color is the proton? Okay, so if the blue color is a proton, then you have 4 positive charges, but only 3 negative charges. So this would be a positively charged atom. Okay, so and we have also, you have also learned this, okay, when you were in doing chemistry. So the proton number is usually given the letter Z. Okay, and Z is defined as the number of protons in a nucleus. Number of electrons equals the number of protons in a neutral atom. Okay, if it is a positively charged or negatively charged ion, where this is a different case altogether. We are only concerned with neutral atoms. Okay, so neutral atoms, the number of electrons and the number of protons are the same. Okay, and this is a very important thing. An element, okay, I'm going to highlight this so that you don't miss it. Okay, an element is identified by its proton number. Okay, the proton number, the number of protons, okay, in the element, okay, which is the number Z, is the one that tells you, oh, okay, this proton number is this element. This proton number is this element. Okay, so this is a very important fact that a lot of people tend to forget lah. Okay, an element is defined, satu unsur itu, okay, dikenal pasti melalui dia punya nombor proton. Okay, or in, a lot of people will say it's called atom number lah, fine. But that's how you identify the element, okay, by the proton number. Okay, on the other side of this one is what we have, the nucleon number. Okay, the nucleon number is defined as the total number of protons plus the neutrons, okay, in a nucleus. Therefore, if we know the nucleon number and we know the proton number, then we also will know how many neutrons there are. Okay, n equals to A minus Z. So if let's say A is 82 and then Z is, let's say, 41. Okay, then we find that the number of neutrons is 82 minus 41 is also 41. Okay, generally, okay, I'm going to say this only in a very general sense. Okay, the number of the number of neutrons and protons are about the same. Okay, generally lah. Okay, of course there are exceptions to the rule, which we will talk about in a while. Okay, but the first thing that you need to understand is what is meant by the proton number Z and what is meant by the nucleon number A. And this brings us to how you write a nuclide. Okay, a nuclide is an atom of a particular structure. Each element has nucleus with a specific number of protons. So this is how you will write the notation. Okay, so example, element X. Okay, then the nucleon number, which is A, okay, always goes on top. And then the proton number, which is Z, okay, will always go at the bottom. Now notice that remember again that the proton number, okay, sorry. Remember, the proton number is the one that defines this element. Okay, so katakan unsur X, okay, is defined by the proton number. Okay, so for example, this one, this is C is for carbon. Okay, so the number 6 at the bottom here is because it's carbon. Okay, there's 6 protons in carbon. So the proton number of carbon is 6. Carbon nucleus has 6 protons. Since the nucleon number is 12, okay, therefore the number of neutrons will be 12 minus 6 will be equal to 6. Okay, of course the question is how many electrons are here lah. Okay, then we have to assume that this carbon atom is a neutral atom. If it is a neutral atom, since there are 6 protons, then there will be 6 electrons as well. So that they're neutral lah. Bilangan charge positif dan bilangan charge negatif mesti sama. Okay, so that it is neutral. If it, okay, we're not talking about ions. Ions is all chemistry part lah. Okay, nothing to do with all physics for now. Okay, so that's how you write a notation of a general nuclide. Okay, now for protons, it's written as 1, 1 because proton is only 1. Okay, and then neutron, since there's no proton, so the proton number will be 0. Okay, but since there's 1 neutron, okay, the nuclear number will be 1. Okay, now electrons is an interesting thing. Okay, there are no protons in an electron because electron is by itself. Okay, but since it is a negatively charged proton, okay, we write it as minus 1. Okay, so this is a strange thing to look at in the first place lah, because we always know, okay, up here is nucleon number, down here is proton number, and suddenly for electron the proton number becomes negative 1. Okay, just remember an electron is a negatively charged, negative charge. Okay, that's why the proton number will be minus 1. And then after this, when we do the calculation, it will all, balance each other out. Okay, you'll find that this minus 1 will really help. Okay. All right. So isotopes, okay, isotopes are also something that you learned in your chemistry. Okay, and the definition for isotopes, I think, is not really much different from your chemistry, right? Isotopes are atoms that have the same proton number. Now remember, all elements are characterized by their proton number. Okay, semua unsur dicirikan oleh dia punya nombor proton. If the number proton is 1, then it's definitely hydrogen. Okay, if the proton number is 6, then it's definitely carbon. Okay, this fact cannot change. Okay, because uh, this is how our forefathers characterized all the elements mengikut dia punya nombor proton. But the thing here is some elements they have the same proton number, but the nucleon number is different. Now remember, the nucleon number is made up of two things: the number of protons plus the number of neutrons. Okay, so since it is made up of the number of protons and the number of neutrons, okay, therefore the nucleon number, okay, okay, uh, the nucleon number may be different, okay, although the element is the same. Okay, take a look at the element, like for example this lah, okay, all three have the same proton numbers, 1, 1, 1. Okay, and we know that the proton number 1 means that the element is hydrogen. Unsurnya adalah hydrogen. But look at the nuclear numbers. One is 1, one is 2, one is 3. Okay, so that means over here bilangan neutronnya 0. Here bilangan neutron is 1 because 2 minus 1 equals to 1. Here the number of neutrons is 2. Okay, so this is what we call an isotope. Okay, isotopes, okay, these three, hydrogen, deuterium, and tritium, okay, are all known as isotopes because they are the same element. Okay, unsur yang sama with the same proton number but different nucleon number. Okay, so isotopes of an element contain the same number of protons and the same number of electrons. Again, assuming that it is a neutral atom. Okay, so isotopes have the same chemical properties. Chemical reactions involve the electrons because chemical reactions involve the electrons in an atom. Okay, but their physical properties will be different. Okay, because ini okay, for example, hydrogen only has one proton right in the center. Okay, hydrogen only has one proton right in the center, whereas deuterium, okay, deuterium has one proton and one neutron. So the physical property is a little bit more heavy compared to hydrogen, but it is still the same. It is still a hydrogen. Okay, it is still a hydrogen element. Tritium has 2 neutrons and 1 proton, okay, in the center, in the nucleus. So it's even more heavy than the deuterium. Okay, but it is still a hydrogen element. Okay, it is just that it is known as an isotope because the number of neutrons are different. Okay, and since their physical properties are different, okay, it is because their mass is also different. Okay, since because hydrogen only has 1, deuterium has 2 things, tritium has 3 altogether. So obviously their physical properties will be different, but their chemical properties, their chemical reactions will all be the same. Okay, so some isotopes exist naturally. Okay, isotopes can also be made artificially. Now, at this point in our study of physics, I think the world of chemistry deals more with isotopes than we do. Okay, but we are talking about this. The reason why we're introducing isotopes is that when we go into radioactivity later, we find that, how come this same element, ni dua-dua sama ni? For example, both are plumbum, Pb. Okay, but the plumbum, the top number here is different. Okay, kita jangan, we don't be surprised lah. Okay, jangan terkejut if you find that, this both is plumbum, but the nuclear number is different. Okay, because as I said just now, the element is characterized by the proton number. Okay, so the proton number must be the same. Okay, the nuclear number can be different, and it's okay because this is what we call isotopes. Okay, this is what we call isotopes, and that actually just basically covers the entire first subtopic, okay, which is actually to a lot of students, this is actually like a revision, okay, revision of the things that you have learned in chemistry. Okay, I'm just going to scroll to see if there's any questions. All I see so far is all attendance. Okay, I guess there is no, yeah, PB is lab, which is which is also the short form of plumbum. Okay. Sorry, when I grew up, I learned it as plumbum, and then only after that I realized that, oh, actually plumbum is also lead. Okay. Okay, there's somebody here called Wan Rahima from KL. Hi, welcome. Thanks for joining us. Okay, if there's no questions, then I'm going to go on into the next subtopic. Okay. Okay, so coming back to our second subtopic, okay, which is radioactive decay. Okay, so now that we have established okay, kita sudah belajar bahawa okay, inside the atom there's the nucleus, which consists of two things, protons and neutrons. Okay, and then at the same time, outside the protons and neutrons are all the orbiting electrons. Okay, and then of course the second thing we have to identify is the difference between the different isotopes. Okay, isotopes are same element, same proton number, but different nuclear number or different neutrons. Okay, so that's a very important thing that we need to know. Okay, so coming back to this one, what is radioactivity? Okay, this definition of radioactivity is very important. Radioactivity is the spontaneous. Okay, I cannot stress this enough. There are two things that characterize radioactivity. Number one, radioactivity adalah satu perkara yang berlaku secara spontan. Okay, it's very spontaneous and it is very random. Okay, it's spontaneous because you don't know when it's going to decay. Okay, and secondly, it's random because you don't know which part is going to decay. Okay, that's what it means. Spontaneous, kau tidak tahu bila. Random is kau tidak tahu yang mana satu. Okay, yang akan mereput. Okay, in Malay it's called mereput lah, but in English we call it disintegration or decay. Okay, of an unstable nucleus accompanied by the emission of energetic particles or photons. Okay, I like to think of radioactivity as somebody with a stomach ache lah. Okay, yeah, somebody with diarrhea or somebody with stomach ache. I hope none of you are having stomach ache at this moment. But radioactivity is something like somebody with a stomach ache. Okay, if somebody with stomach ache, you don't know when you have this constant pain in your stomach. And that's what you mean by, like the instability. There's this unstable part in you. And you don't know when you're going to go to the toilet because you don't know, belum ada feeling. Okay, and then, of course, well, I can't really say okay, the word random, but the point is you don't know when you're going to go to the toilet. Or you don't know when you're going to feel the pain again. Okay, so radioactivity is something similar to that. Okay, it is a spontaneous and random disintegration because the nucleus is unstable. Okay, whatever nucleus we have, that nucleus is unstable. That's why it needs to disintegrate. Dia perlu terurai atau mereput. Dia perlu mereput. And when we say mereput in terms of radioactivity, dia bukan macam, dia bukan macam mereput yang like reputan, like the decay of flesh, or if something dies, then the skin, decay. Not that kind of decay. Okay, but radioactivity is really the disintegration of an unstable nucleus. So the nucleus itself is unstable. Then a part of it has to come out. Okay, has to decay. Okay, so that it becomes a more stable nucleus. So there's actually a word that is missing here. Let me see. Radioactivity is a spontaneous and random disintegration or decay of an unstable nucleus accompanied by the emission of energetic particles or photons. So what actually is being emitted, what actually is being decayed is energetic particles or photons. Okay, the same thing. Energetic particles can also be known as photons. Okay, but the point is this. Okay, the nuclei of some atoms are unstable. Okay, this is a fact of life. Some atoms, when they exist naturally, they are unstable. And something that is unstable will definitely want to be stable. So how do they become stable? They will decay. Okay, they decay, and the point is to become more stable. Okay, by emitting radiation in the form of a particle or electromagnetic radiation. Okay, so this is what the real meaning of radioactivity means. Okay, whenever we say radioactive, people only think of that sign, and then people think of the skin melting and everything. That's all the effects of radioactivity. But actually, radioactivity is a natural process that happens all around us. Okay, it's just that sometimes we don't, most of the time, we don't feel the effect. But actually, it's always happening. Okay, it's always happening, but the point is this lah. We don't know when and we don't know how. Okay, so this meaning here, so the random process. Okay, random process means, random process means there's no way to tell which nucleus is going to decay, and you cannot predict when it is going to decay. Spontaneous means that the process is not triggered by any external factors such as temperature or pressure. Means you cannot force it to decay. Okay, it is a natural process in itself. So it's random because we don't know which one, and it's spontaneous because we don't know when. Okay, because you cannot push it to decay. Okay, it will just decide to decay by itself. Just like, when you have, I'm going to use this example again. Just like when you have diarrhea lah. Okay, when you have diarrhea, you don't know when you're going to go into the toilet, and you don't know when it's going to end. Okay, so you will continue to go to the toilet until you finally become more stable. Okay, which is usually because of eating medicine and everything. Okay, so some similarities there lah. Okay, but not fully similar lah. Okay, so that's what it means by radioactive. All right, so there are three types of radioactive, there are three types of radiation. Okay, the first type is called alpha radiation. The second one is called a beta radiation, and the third one is called a gamma radiation. Okay, now the alpha radiation is always characterized by this letter alpha, which, I'm going to write it in pen. This highlighter is not helping. Okay, so alpha is written like this. Okay, just like how we write alpha and beta when we learn maths lah. Okay, and then beta is of course like this. Okay, and then the gamma symbol is this way. Oh dear, so ugly. Let me try again. Yeah, this is the gamma symbol. Okay, it looks like a fish that is it looks like a fish that is swimming downwards lah. Okay, so that's how the radiation is characterized lah. Okay, alpha, beta, and gamma. Okay, there are three types of radioactive emissions, and in terms of their nature, this is their nature. Okay, so we're going to look at alpha. And alpha decay. Okay, and alpha radiation. So actually, apa yang keluar, okay, what is actually being decayed, okay, is a helium nuclei. Okay, and the helium nucleus has 2 for the number of protons and 4 for the nuclear number. So, or basically 2 protons and 2 neutrons lah. Okay, that's an alpha decay. So whenever a nucleus decays, if it is an alpha decay, means okay, alpha decay means ada helium sudah yang terkeluar, yang terreput. Okay, and the helium is very standardized. It's always 4-2. Okay, so we always call this helium 4-2. So it's easy for us to remember. Okay, now the second one is the beta decay. Beta decay means that the thing that is being emitted, benda yang terpancar. Okay, the thing that is emitted is actually just an electron. And we've seen this before, an electron, the way to notate the electron is E0 -1, because the charge is -1. Now, the most interesting of all is the gamma decay. Whenever something decays and, the only thing that is emitted is a gamma radiation, it is actually just an electromagnetic radiation. Okay, there is no atom that comes out of it, there is no electron that comes out. It's just a ray. Okay, if you remember when we studied electromagnetic waves in chapter 1, we learned that gamma ray is just a ray. Okay, it's just an electromagnetic wave. So it's something like that. Okay, now if I'm going to put it very crudely, this is very crude lah. Okay, and since we're talking about diarrhea, alpha is very heavy. So when you have diarrhea, you have all this, when you defecate lah. Okay, so it's very heavy stuff lah. Okay, and sometimes it can be all this very light stuff, which is like beta. And then gamma is just no stuff comes out, but there's a lot of gas. Macam like your fart lah, when you're farting like that lah. Okay, I know it's very crude way of exemplifying this lah, but this is how I find it easier to remember. Okay, alpha is the heaviest. Beta is a little bit, and then gamma is just like that. That's it. Okay, but now interestingly, okay, which we will come to in a while, we find that gamma radiation is the most dangerous radiation of all. It's the most dangerous of the three lah. Okay, of the three emissions, alpha, beta, and gamma. Okay, gamma is the most dangerous. Okay, just like your farts lah. Okay, the farts are usually what they call silent killers. Okay, so yeah, something like that lah. Okay, so now we find that in terms of the mass, Okay, since alpha is very heavy, 2 protons and 2 neutrons, it is the heaviest of the three. Okay, gamma, as I said, it's just put like that. Okay, it's just one big radiation. Okay, so there's no mass actually because there's nothing that comes out, it's just a radiation only. Okay, and then in terms of alpha, alpha is a positive charge because it is a helium nuclei. Okay, and then beta is a negative charge, okay, it's an electron, and then gamma, again, because there's no charge, it is just a radiation, okay, it is neutral. Okay, now these next three, speed, ionizing ability, and penetrating power and stop by are all related. Okay, now we find that alpha being the heaviest, okay, it is also the slowest radiation. Okay, whereas gamma, since it's the lightest, virtually no mass, okay, it will emit at the speed of light. Okay, and remember the speed of light is 3 times 10, oh dear, 10 to the power of 8, okay, meters per second. It is an extremely fast radioactive emission. Okay, compared with all three, alpha is the slowest because the heaviest, okay, and gamma is the fastest because all electromagnetic waves travel at the speed of light. Okay, don't forget that. Now, because it is slow, okay, because alpha is slow, okay, it is easy for us to ionize the alpha radiation. Okay, we will talk about ionizing ability a little bit later. Okay, because dia bergerak dengan sangat lambat, it is easy for it to ionize all the air around it. Okay, whereas since gamma is traveling so fast, it has very little time to ionize all the air that is around it. Okay, we'll talk about this ionizing ability in a little while, but I just want you to know that because of the speed, okay, this is all related. Okay, because alpha is slow, it can ionize everything else very easily. But also because of that, because alpha is slow, the penetrating power is very low. Okay, penetrating means dia punya kuasa penembusan, how how good it is untuk menembus halangan. So we find that alpha emissions are easily stopped by a few centimeters of air or a piece of paper. Means if you want the alpha decay to stop, if you want the alpha emission to stop, okay, you just have to put a paper in front of it, then it'll be terhalang. It'll be terhalang sudah lah. You just put a piece of paper, you have alpha, then it'll be stopped. Okay, because the penetrating power is so low and the speed is so slow that it's like, stop. Okay, but gamma on the other hand, since it's traveling so fast, okay, it is able to penetrate a lot more. Okay, and in order for us to stop gamma, okay, we need a few centimeters of lead or otherwise known as plumbum lah. Okay, so if you have a radioactive sample, okay, if you have a radioactive sample, holding it, you don't keep it in a Tupperware like this. Okay, you keep it in a box. You keep it in a box that is a few centimeters thick, and the box must be made of lead or plumbum. Okay, so that because as I said, you don't know what is going to be emitted. It's so random, it is so spontaneous, you cannot predict. Susah untuk kamu meramal mana satu yang akan keluar. Is it going to be alpha? Is it going to be beta? Is it going to be gamma? So be safe. Okay, if you have a radioactive sample, you will keep it in a box. Okay, that is a few centimeters thick and it is made of lead. Okay, because lead is the only one that can stop all three. Okay, it can stop alpha, it can stop beta, it can stop gamma. Okay, if you are going to put the sample okay, inside a Tupperware box like this okay, then you will probably only be able to stop alpha and stop maybe, okay, you can stop beta from coming out of the box. But gamma will just, penetrate through the box, and then whoever is holding the box is going to be radiated. Okay, and then, of course, you've seen enough movies to know what radiation does to you. Okay, so it's important for us to know these 4 things. Okay, the speed, the ionizing ability, and the penetrating power, and what it can be stopped by. Because it's all, it is all linked together. It is slow because it is heavy. Okay, alpha is slow because it is heavy. And because it is slow, the ionizing ability is high, the penetrating power is low, and it can be stopped by a few centimeters of air and a piece of paper. Okay, the last one is, can this radiation be deflected? Dia boleh ke terpesong, okay, by electric and magnetic fields. Now, the only one that we find that cannot is gamma. And the reason why it cannot is because it is a neutral atom. Neutral atom is not neutral atom is not affected at all by anything positive or negative, by magnetic fields, totally not affected. But because alpha and beta, they are positive and negative charge. Okay, so it still follows the laws of physics lah. Anything that is positively charged will be attracted, okay, to something that is negatively charged. Okay, so if you put an alpha, if you put an alpha atom, if you put a helium atom through a negatively charged field, the helium atom will be tertarik towards the negative side lah. Okay, that's very natural. It still follows the law of physics. The only one that is not affected, it will just go straight on, okay, will be just gamma, because gamma is neutral. Okay, and then on top of that, okay, gamma is also traveling too fast. Okay, it's traveling very fast, and it cannot be that easily deflected. Okay, so these characteristics are important for us to know in terms of alpha, beta, and gamma. But let me see. Okay, hold on. Okay, so we're going to talk about these two in a while. Okay, the ionizing ability and the penetrating power. So the first is the ionizing effect. Okay, radioactive emission has an ionizing effect. Okay, the three types of radiation are highly energetic and use their energy to remove electrons from the air molecules. This is what is known as the ionizing effect. What are they ionizing? Okay, they are ionizing the air around. Okay, so that means now when a radiation goes through the air, that let's say this is the ionizing thing lah. Okay, so when it passes through the air, okay, all the air around it will be ionized. Means that it's going to menarik all the electrons. Okay, it's going to tarik all the electrons to come to it lah. Okay, which is why the ionizing effect of helium is very high, because it is a positive charge. Okay, it is a positive charge and it's very heavy. There's two protons in there. So definitely the electrons that are super light are going to be attracted towards the helium atom. Okay, so the ionizing effect of the alpha atom, okay, which is the helium atom, okay, is the highest. Okay, because the ability to remove the electrons from the air around it, okay, is very high. Okay, and that's why it's called the ionizing effect. You are ionizing, menjadikan ion. Okay, in Malay, it's called pengionan. Okay, apa yang kau kasih ionkan is the air around it. Mengasih ion means to remove the electrons. Okay, so the three types of radiation are highly energetic and use the energy to remove electrons from the air molecules when they pass through the air. The ionization of an atom produces either a positive or negative ion, which is an electron, depending lah. Okay, now due to the different charges and masses, they have different ionizing abilities. Okay, now this is what we call a cloud chamber, which I will talk in the next lesson. Okay, but if we see in a cloud chamber, I've done this experiment only once, and it was last year. We were trying to do it yourself cloud chamber. Okay, I think I have it in school, but I don't remember whether I have the bahan for it. But I remember when we were looking at the alpha, beta, and gamma, the most visible was alpha. You see all these shoot, all the ionizing effect is characterized by the smoke. Okay, you will see some form of smoke. Okay, actually it's not really smoke. It's just, it's just water vapor. Sorry, it's just vapor. Okay, vapor that has been, looks like mist like that. So we find out that if this is an alpha decay, we find that the tracks, okay, the tracks will be very straight and they'll be very fast. Okay, so the alpha particle has a large mass and momentum, so it's not easily deflected. So alpha is all straight. But beta, since the tracks are curve. Okay, so this one, short, thick tracks which curve in random directions. Okay, means that the beta particles are slower. Okay, whereas if they are thin and straight, they'll be very fast beta particles. But you find that the ionizing power is not so high. Okay, actually beta is a little bit difficult to see. Alpha is the easiest to see. Okay, it's very straight and it's thick, and it's very easy to see. Gamma, on the other hand, is the most difficult to see. I don't think I've even seen the gamma gamma track when I was doing the cloud chamber experiment. Okay, the tracks are not clear or continuous, low ionizing power. I will show a video lah. I will show a video. I will pass it to your respective groups later of how the cloud chamber, the tracks look like. Especially in the alpha. Alpha is the easiest. You will find that when you see the video the tracks are just very straight, very nicely seen. Okay, because the ionizing power, this proves that the ionizing power of alpha is very high. Okay, it's able to ionize so very, very nicely and very clear to be seen. Okay, but the point of this slide is this lah. To understand that the ionizing effect is to remove the electrons, mengionkan the air. Okay, it's to ionize the air around the element, around the atom itself. Okay, and how they ionize it is to remove the electrons from the air molecules when they pass through the air. Okay, penetrating power. Okay, penetrating power, as we explained just now, okay, depends on the ionizing power. The radiation which has a stronger ionizing power, okay, has a lower penetrating effect. This is a fact of life because stronger ionizing power means it's slower. If it's slower, means it's able to be stopped much easily. Okay, so it's sangat lambat. Okay, we find that actually even here, inertia plays the second law. Okay, momentum, okay, also plays an effect because the velocity is so slow. Okay, so it's easy for us to stop it, even though the mass is very high. Okay, but since the velocity is so slow, okay, it's easy for us to stop it. Manakala gamma is so fast, it's moving at the speed of light, 3 × 10⁸ meters per second. So definitely, it will be much harder to stop as opposed, and it can only be stopped by a few centimeters of lead, okay, which is plumbum. So alpha particles lose energy very quick as they move through a medium. So after a short distance in the medium, the alpha particles would have lost almost all energy. Okay, so alpha particles have the lowest penetrating power because whenever it passes through a medium like this, it will lose energy. Okay, sebab banyak resistance lah. Okay, so dia mau juga tembus, tapi because there's so much resistance, they will lose the energy trying to fight the resistance. Okay, and in doing so, they will be stopped. Okay, they will not be able to penetrate. Whereas beta particles, okay, they can be stopped by paper, okay, but they will be stopped by a thin metal. Usually a few centimeters of aluminium will be enough. Okay, gamma rays, however, can go through paper and metal sheet. Okay, so it can go through paper, can go through aluminium because the penetrating power is high. It doesn't lose so much energy when it goes through paper and aluminium. But the moment you kasih jumpa dengan lead, okay, then that's where it will start to lose energy. Okay, it's true that this part maybe some of you are asking how come it can still go through that? Because gamma radiation is no joke, Okay, it's very high energy particle. Okay, so obviously most of it can be stopped, but there will be some. Okay, it is not foolproof. There will be definitely some that will still have enough energy, okay, to penetrate through that. Okay, and that's pretty normal. Okay, so don't be surprised. But generally, generally we find that yes, it can be stopped by a few centimeters of lead. Okay, I don't know how the weather it is like where you are, but over here where I am, it is raining, and I'm very thankful for the rain because it's been very hot for the past few days. Okay, so I'm thankful that it's raining now. Okay, so we are going to go into the next part. Okay, as I said just now, with the electrical field. Okay, so we find that gamma rays, they are totally not phased at all by electrical field. Okay, alpha will be, will be deflected towards the negative plate, and beta, since it is a negatively charged particle, it will be deflected into positive plate. Okay, now why is it that the deflection of this deflection, okay, dia punya pesongan oleh beta adalah lebih besar. Look at the angle, okay, the angle is so much more bigger here than for alpha. Okay, and the reason is this because the mass of beta is so much smaller than the mass of alpha. Alpha is a helium 4-2. Okay, 2 protons, 2 neutrons. So it's very heavy. Since it is very heavy, it is going to take a while for it to be terpesong. It will definitely terpesong, but it will take a while. So because of that, the deflection is smaller. Okay, dia punya pesongan adalah lebih kecil. Manakala beta, beta is just one electron. Okay, the moment you put a positive plate over here, it will be shoot. Okay, you just like automatically want to go over there because it's so light. Okay, and of course, gamma rays are not deflected because they do not carry any charge. Okay, so there is a difference, guys, between the alpha deflection and the beta deflection. Beta deflection is bigger because beta is lighter. Okay, it's just one electron. Magnetic field. Alpha particles and beta particles are also deflected when they pass through a magnetic field. Okay, just like this. And the same, okay, this Fleming's left-hand rule, we have not learned it. Okay, this is chapter 3. Okay, but suffice lah for now. Okay, cukup untuk kita mengetahui bahawa the same rule that happens in the electrical field applies. Okay, applies in the magnetic field. The alpha particle is harder to deflect. Okay, than the beta particle. The beta particle is so much more easier to deflect. Okay, senang untuk kita kasih pesong because the mass is so much smaller. Okay, so I'm going to pause here for a while just to see if there's any questions. I know today is kind of a long lecture, all lecture. But I just want to see if there's any questions. Let me just scan through. Okay, so far I don't see any questions, so I guess no, I hope that you all understand now what we are saying, because soon we're going to go into some small calculation part lah. Okay, so okay, if there's no questions, I know there's a slight lag of about 10 seconds, so if you type any questions, and this live chat feature shows me the conversation like much later. Okay, so it's okay. If you have any questions, just keep posting it, and then I will answer it in a while. Okay, coming back to this. So when we talk about radioactive decay, okay, this is the calculation part already. We're going to come to this. Okay, so radioactive decay is again is a spontaneous and random process by which unstable atomic nuclei, okay, emit subatomic particles or radiation. Okay, and we find that alpha decay, if the original nuclide, okay, if the original nuclide is element X, okay, with a nucleon number A and a proton number Z, and if it is an alpha decay, what will happen is it will become a new element. Okay, it will become a new nuclide where the number of nucleons, okay, -4, and then the number of protons will be -2, because 2 is already taken out of helium. Sorry, 2 is already taken out, okay, already decayed to become helium, and then of course another 2 neutrons, okay, which makes up the nucleon number 4. So this number here will be -4 and -2, and then this will become 4-2. So this is an example of an alpha decay and how to write the equation. Okay, the equation for an alpha decay. Okay, so if you notice here, this is balanced out lah. A -4 plus 4 is A. Z -2 plus 2 is also Z. Okay, so ingat saja, alpha decay, the new element will be -4 -2. Okay, nombor di atas tolak 4, nombor di bawah tolak 2. Okay, and then of course you need to write the helium. This one mesti kau ingat lah. Okay guys, this one is not in a buku formula or anything. You have to remember what the element is for alpha decay. Okay, just remember it's helium 4-2. Very easy to remember. Okay, secondly is the beta decay. Now if the beta decay happens, we find that an electron comes out. Okay, sorry, an electron is emitted. Now since an electron is emitted, okay, then what will happen is the number of nucleons remains the same. Okay, after decay, A is still A. Okay, because A plus 0 is A lah. But we find that the number of protons will add by 1 in order to balance this out. Okay, so this will be Z plus 1 plus -1, which will give you Z. Okay, so if you are given a situation and you're asked, is this an alpha decay or beta decay? Just remember, if the A is the same and the Z increased by 1, then it is a beta decay. Okay? So, difference between alpha. Alpha is upstairs -4, downstairs -2. Beta decay is upstairs don't change, downstairs tambah dengan 1. Okay? Now, gamma decay. Now look at this. Gamma emission does not change the structure of the nucleus. It just makes it more stable. So the element is still the same. Okay, gamma rays are emitted at the same time together with either an alpha or beta particle. Usually, okay, this is another thing. Sometimes all three decays can happen at, oh no, sorry. Sometimes alpha decay will happen together with gamma decay. Sometimes beta decay can happen with gamma decay. Okay, so gamma decay usually doesn't stand alone. Usually it will be together with alpha or beta. But the point about this is this. Gamma decay, okay, what happens to the element before and after? No, it remains the same. The only difference is that it has become more stable. Okay, so when the nucleus ejects an alpha or beta particle, okay, there is often some excess energy produced, which will be released as gamma rays. Okay, and this is how we write the equation for alpha, beta, and gamma decay. Okay, so this is an example. Okay, this is an example that we show you here. Okay, so for example, for alpha decay, so TH is the element for thorium. Okay, THORIUM. Okay, I don't know whether it has anything to do with our Avengers Thor, but let's not go into that now. Okay, it's thorium, thorium 90. Okay, so 23090. So if it is an alpha decay, what happens is it will emit the alpha particle, which is helium. Okay, so helium 42, and then of course there must be energy lah. Okay, but we find that the 230 tolak dengan 4 will become 226, and then 90 tolak dengan 2 will become 88, and it becomes a new element Ra, which is radon. Okay, Ra is radon. Now, some of you may be asking me, alamak, how are we supposed to know 90 is thorium, 88 is radon? Macam mana kami mau tahu? Okay, this one you're not expected to know. Okay, usually if in an exam question, they will tell you. Okay, they will tell you what the element is lah. Okay, but the calculation itu yang kamu kena faham. How did the 90 become the 88? Because kita tolak 2. How did the 230 become 226? Because kita tolak 4. Okay, the element itself, nama element itu biasanya diorang akan bagi. So don't worry about it. Okay, you're not expected to memorize the entire periodic table. Okay, so another example here is uranium. Okay, U is for uranium. So uranium 238, okay, and then the proton number is 92. If it is an alpha decay, it will decay to become thorium 234 and 90 because -4, and then this one will be -2. Okay, notice that once again, look at this situation. This is thorium 23490, but this is also thorium, but it is 230 and 90. So what are these two called? These two are called isotopes because they have the same proton number but different nuclear number. They're the same element. Both of them are thorium. Okay, both of them are thorium. Okay, it's just that one is 234 and then the other one is 230. The nucleons are different. Okay, but they are still thorium, TH. All right. Okay, so generally, when we write decay, we always write plus energy at the end because there's always some energy emitted. Okay, itu element bukan just terkeluar and then duduk diam saja tau. Okay, you will travel and you will have some energy going, from it lah. Okay, an example of beta decay, how to write now. Okay, notice as I said just now, nombor di atas tidak berubah. Okay, from chlorine to from carbon to nitrogen. Okay, this is carbon 14 and this is nitrogen 14. Okay, is still from carbon to nitrogen, we find that the nuclear number doesn't change, but because it is a beta decay, the proton number increases by 1. Okay, from carbon becomes nitrogen. Okay, plus the beta element, the beta particle and energy. Of course, energy kita mesti letak at the end. Okay, now, same thing happens here, plumbum 209. Okay, if it is a beta decay, there's no increase in the nuclear number, but there will be an increase in the proton number. Okay, so 82 will become 83, and then plus the beta particle and then energy. Okay, this is a normal one. So it's important for us to know, okay, which decay we're talking about. And usually at this point, when you're studying radioactivity at the introductory level, usually they will tell you, okay, for exam purposes, they will tell you. Now, in a gamma decay, okay, this is an example. I'm going to start with this. Okay, this is an easier one. Okay, this is a gamma decay where the element doesn't change at all. Okay, 60, 60, 27, 27, cobalt is still cobalt. Okay, but there's a gamma radiation. So it's just plus gamma. And we don't write energy because usually gamma is already energetic in itself. Okay, now this is an example of a gamma decay that happens together with what decay is this? This is alpha decay. Okay, so we find that polonium 21084, polonium, okay, will decay to become plumbum 20682. When the numbers change, then you know that one of either alpha atau beta sudah, terpancar. And since this is a -4, this will be helium 42. Okay, and it is balanced like 84 and 82 balanced by 2. Okay, so this is an example of how to write the equation. Okay, so next point. Sometimes the daughter nuclide of a radioactive, this is something, is still unstable. Okay, after you decay, let's say, okay, for example, this one, after polonium becomes plumbum, right? Okay, sometimes it is still unstable. It is more stable. This plumbum adalah lebih stabil daripada polonium, definitely, because already decay but it can still be unstable. Dia masih tidak cukup stabil. Okay, so this plumbum may decay into another nuclide, which could also be unstable. So decay, 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 decay. So this process continues as a radioactive decay series until a stable nuclide is reached. Okay, each decay will either emit an alpha or beta particle and maybe gamma rays. Okay, so as I said, because it is so spontaneous and it is so random, we don't know how it's going to decay. We don't know when it's going to decay. Okay, this much we know. Okay, but for when we answer exercise questions, we live in a perfect world, so they will tell you how it decays and everything. So don't worry about that. But in reality, all radioactive researchers, all nuclear researchers know that because it is so spontaneous and random, you cannot leave everything to chance. Okay, you have to take all sorts of precautions, okay, because you don't know. Oh, okay, after decay one time, is it stable already? Is it stable? We don't know. Maybe it's still unstable, so it will decay again. So it will continually decay, okay, until it becomes something that is more stable. Okay, so this is what we call a radioactive decay series. Okay, just to show you that this thing is not just one time only. Okay, maybe after thorium becomes radon, and then radon becomes something else, and then something else becomes something else. It will continue to decay. Okay, so they're not just one time lah. Dia bukan satu kali decay terus stabil sudah. No, it's not. Reality is you will continue to decay until it finally becomes more stable. Okay, so usually it is not stable after one time decay. Okay, so this last part we're going to do a couple of exercises. I'm going to let you see these questions for a while. Okay, and then we're going to answer this lah. Okay, so uranium-238 emits an alpha particle, decays into a thorium atom. Okay, state the nucleon number and proton number of thorium, the isotope form, write an equation for this decay. Secondly, I ask you to complete this. Okay, miss the two numbers over here are missing lah. Okay, then the third one is strontium-90 decays to yttrium, okay, by emitting a radioactive particle. Now, as I said before, all these things usually will be given to you. Okay, you're not expected to remember what is yttrium punya chemical formula. Okay, it's basically Y lah. Okay, so write an equation and then what particle is emitted. Okay, so let's take a look at this. Okay, so the first one, okay, sorry, I'm going to have to revert to this already. So, okay, I'm going to prop this up so that you see the board a little bit better. Let me see if I can do this one. Okay, I hope you can see the questions and you can also see me at the same time. Something like that. Okay, so we find the first question. Okay, question number 1. We find that uranium-238 92 emits an alpha particle. Okay, alpha particle and decays into a thorium atom. Now we know that for alpha particle, okay, it is actually a helium-4 2. So when it emits the alpha particle, we know that at the back over here is 4 2 helium plus what is the important thing that needs to be included at the back here is called energy. Okay, I know that you can't see the word energy here, but just remember to write energy lah. Okay, my point is this: what happens over here? So they say that the atom that it decays into is a thorium atom. Now thorium is TH. Okay, now let's balance this out. Okay, if there's 2 3 over here and then there's 4 over here will be 2 3 4. Okay, and then 92, and since there's 2 over here, 2 already taken out. Okay, therefore this will be 90. Okay, so this is the answer for the first one. Okay, the equation for this decay will be written in such a way, in this way. Okay, let me show it to you. Okay, this is how it will look like. Remember to write energy at the end here because we don't know. We don't know whether there's going to be a gamma decay, okay, for this. Okay, but usually it will be paired up, okay, together with some form of energy. Okay, second question. Second question. Okay, second question says, okay, complete this one. So it gives us 21092, sorry, 82. That's 92 is not quantum. It's a quantum 82. Then, of course, it decays into this. I think this is Byzantium plus and beta particle. Okay, so we are given this. Okay, 210 plumbum, 21082 plumbum decays into this. I think it's called Byzantium. I'm not really sure. Okay, and electron. See, even I'm not really sure. See, I don't remember all this one. Okay, usually it's, you know, we check the periodic table. Saya cakap Byzantium. Okay, so let's balance this out. Okay, this is just like any normal chemical equation balancing. 210, and since this is a beta particle, okay, the number on top doesn't change. It will still be 210. Okay, manakala 82, and since this is -1, we find that the proton number must increase by 1. Okay, and this will be the answer for number 2. Okay, just to give you an idea of how the decays work, okay, and how to complete the questions. All right, third one. Third one is strontium-90 decays into yttrium-90 by emitting a radioactive particle. So they give you over here that strontium-90 is 38. 90, 38 decays into yttrium. I like to say this is yttrium. Yttrium-90 and 39 plus don't know what. Okay, so write an equation for this decay. So let's write this equation. Let's take a look at it. Okay, let's take a look at this. We find that the nuclear number doesn't change. The moment you see the nuclear number doesn't change, then there's nothing to think about. You know that up here is going to be 0. 38 will become 39. To balance this out, we need to minus 1. So this is an electron. So what particle is this? This is a beta particle. Okay. If you want to make this even more complete, write energy at the back here. Okay, then it's even more complete. Okay, so strontium, yttrium emits beta particle and energy. Okay, so this is an example of okay, yes. Since somebody asked me, quite a number of people asked me this. Okay, number 2, you need to write energy, and also Timothy Thomas. Okay, fine, you can write energy. It's just that the question didn't write energy over there. Okay, so if you look at the question, sorry. Okay, if you look at the question, dia tidak tulis energy. That's okay. I guess you can write energy as well. Okay, it's still, I think it's still valid. Okay, maybe that's what they mean by complete the question. Okay,
Let me see if I can. Let me see if I can this one. Okay, let me share this screen with you. Okay, I think the next screen is the answer. Yeah, that's it. Oh, the tulis like energy. Yeah, so maybe it should have energy lah. I think there should be the word energy over there. Okay, so just all right. So actually, you see, it's not that difficult. In terms of calculation, it's not that difficult. The difficult part about this subtopic actually is understanding how the decays work, and especially understanding the characteristics. Okay, which is why I spent such a long time talking about the characteristics, because understanding the characteristics of each and every particle, will definitely help us to understanding how each and every particle how each and every decay works, okay, definitely helps us to understand, okay, why the particles act the way they do. Why is their ionizing power high? Why is their penetrating power low? Okay, it all has to do with all the physical properties of the of the particle in itself. Oh, okay, everyone. Thank you, Salfarina, for this. B is bismuth. Okay, bismuth sounds like bismuth sounds like a element that I find in Final Fantasy. If I don't remember. Okay, here's another question. Do your marks? Oh, hello, Audrey. I don't know which school you're from, but thanks for this question. Do your marks get deducted if you forget the energy? I think generally no. Um, generally no, but I think it differs from year to year. If you're really talking purely exam questions, okay, I would say that it depends on the marking scheme of the year, and it also depends on how strict they are for that particular year. Okay, they may be strict and say, oh, you must write energy. Okay, but I would say that to be on the safe side, okay, we must understand. I think it shows a little bit of understanding on our part lah. If we say that if we write down there that there is plus energy, because it shows that we understand that all radioactive decay has a release of energy. This one is definitely cannot be fought on. Okay, everybody agrees that this when a radioactive decay happens, definitely there will be a release of energy. So I don't think it is wrong if you. I don't think it's wrong to just add the word plus energy at the back. But I understand sometimes you forget. Okay, sometimes you forget, and I really cannot answer whether your marks will get deducted if you forget the energy lah. I hope it doesn't. Okay, I hope it doesn't. But I think it also depends on the examiner itself and how strict they are with the marking scheme. Okay. Sir equals to beta particle can write as electron. I'm not really sure what you mean by this question. Beta particle can write as electron. Yes, the beta particle is an electron, but write as electron means right where? That's my question. If you're saying, if you're saying that if I want to write here, okay, I hope I understand your question. If you say if you want to write it as electron, okay, I would say no problem lah. Okay, but if you are saying that 90, let's say yttrium 39, okay, yttrium 39, and then you write over here instead of 0 minus emitted beta particles. Okay. This one I show you now. Okay, if you write this one definitely cannot. Okay, I'm gonna say I'm gonna write it. I'm gonna show this to you. Okay, if you write it as yttrium 39 plus beta macam ni, definitely cannot. You need to tell me what the beta particle is. Okay, which is 0, -1, and electron. Your question is emitted beta particle. Yes, I think it is not wrong. I think he's trying to qualify this. If you write the electron, the emitted beta particle as an electron, I think it is not wrong. Okay, you can write both also if you want, but actually it also depends on the question. Some questions will say, what is the beta particle? I think you cannot write the beta particle as a beta particle. Okay, so you can write it as an electron. If the question says, what is in a radioactive decay, okay, what kind of particle is the electron? Then you have to say the kind of particle is a beta particle because it wants you to identify the electron as a beta particle. Okay, so a beta decay, I mean, it's an element that is decayed out during the beta decay. Okay, so I hope that answers your question. Thanks for the questions, everybody. Okay, we're going to continue. Let me see. Okay. Is there any more? Oh, there's another two more. Okay. Oh, there's actually another two more pages. Now we're going to come to this. This is where the stuff gets a little bit harder. Read the questions first. Thorium 232 decays to plumbum 208. Now, take a look at the numbers. It's not so straightforward anymore. Okay. Thorium 232 decays to plumbum 208 by emitting alpha particles and beta particles. Determine the number of alpha particles and beta particles being emitted. Okay, so this is the hard part. Okay, so we have thorium 232 and we are given is 90. Okay, goes through a series of things. Sorry. Okay, hope you can see the question now. Okay, goes through a series of things and then finally becomes, oh dear. Oh, sorry. Finally becomes plumbum 208. Okay, plumbum 208. Now, this is what I meant. Okay, this is what I meant when I said that, you know, it's not just one-time decay. Okay, continually decay. So we find that, look at this number, 232 until 208. It's a lot of decays. Okay, from thorium all the way to plumbum. And then we find that the proper number, in the end, it increases to become 92. Okay, so how is that possible? Okay, now the way that I will approach this question is usually by trial and error. Okay, and since the alpha particle, since the alpha decay has the most number of changes, you minus 4 on the top number and you minus 2 on the bottom number. So I would do that one first. Okay, but the thing is this how what the elements are, okay, apa dia punya element itu is not important for us to know. Okay, if you want, okay, if you really want, you can put them in, you can look at the periodic table and look at it lah. Okay, just like Safarina just now, I don't know where she found this from, but thank you for this information. Okay, BI is Bismuth. Okay, so we have to do a trial and error with this. Okay, so let's say, okay, 23290 I'm going to start here. 23290. Okay, after one alpha, let's say decays one time alpha, because we know starting is here, ending is here. We want the end here. Okay, so let's see how it happens. So 23290 thorium, if it is alpha, will be 232 minus 4 will be 228. And then 90 minus 2 will be 88. Okay, whatever the element is, I'm just going to call this X element. Okay, because I also don't know what it is. Okay, so after alpha decay, 232, tolak 4 dari 228. 90 minus 2 become 88. Look at this 228 and this 208 now. Far more. Okay, so let's continue. So 228 minus 4 and another minus 2 will become 224 and 86. Okay, I know we're going very far away from this 92. Okay, but don't worry about this. Let's just keep going on. I'm going to call this element. Oh, cannot be element Y. This cannot be element Y. I'm just calling it element X again. I don't know what it is. Okay, and I don't care. If you guys are very rajin and you want to tell me what is 88, what is 86, go ahead, write it in the chat box and I will put it in. Okay, let's keep continuing. 224, we're going all the way to 208. So 220, 84. Okay, and then after that, 216, 82. And then after that, 216 minus 4, 212. Okay, and 80. And then finally, we are able at 208 and 80. 78. Okay, so if you look at it, it takes us 1, 2, 3, 4, 5, 6 alpha. Okay, 6 alphas. Okay, for us to reach from 232 all the way to 208. Plumbum 82. I guess it's 82. Okay, fine, plumbum. If you want to tell me the rest of the design, go ahead and tell me. Proton for plumbum, yeah, can plumbum 82. As I said, okay, all these number elements not important. Okay, if you remember, you remember. If you know, you know. If you don't, the important thing is I want to know how many alpha and betas have passed. Okay, for us to get from 232 to 208, it's 1, 2, 3, 4, 5, 6 alphas. Okay, but our problem is we want 92. I don't want 78. Okay, so if I'm going to go from 78 to 92, but I want to maintain the 208 number on top, which means that we need to talk about beta particles. Okay, now we know that beta particle is a 0, -1 electron. So every beta particle that decays is a +1 to this bottom number here. So 78 to 92. I'm not going to draw the whole thing out. Okay, so how many beta particles are we talking about? For us to get from 208 to 92 of number. 92 ka? Sorry, am I reading the question wrongly? Sorry. Oh, 82. Okay, sorry, my mistake. 82. Okay, sorry, my mistake. Okay, 82. Okay, 82. So 78 to 82. Thank you. So 78 to 82 is how many plus? So 78, 79, 80, 81, 82. So we're talking 4 beta particles. So it takes us 6 alpha decays and 4 beta decays. Okay, 6 alpha decays and 4 beta decays for us to go from 23290 thorium all the way until plumbum 82 with 208. This one. Okay, so I find that sometimes the best way is to deal with the biggest number first. Okay, start at the alpha, because the alpha has the biggest number of changes until you get to the nuclear number that you want. Because we know that the proton number only changes, in order for us to change the proton number before changing the nuclear number is by doing a beta decay. Okay, so yeah, sorry to whoever that said, because quite a few people of you said 14 beta. Okay, and this David Johannes also. Okay, so yeah, sorry. It's supposed to be 4 beta. Okay, because I miscalculated. Okay, I thought this was 92, but actually it's 82. Okay, but thank you. 4 beta. 78 to 82. 78 plus 1, 79. 80, 81, 82. So you need to have 4 beta. Okay, so the answer will be 6 alpha, 4 beta. So again, to approach this question, okay, we need to look at it in terms of the alpha first, because the biggest number of changes there. Then after that, you adjust it by putting the beta. The question is there going to be gamma radiation? Okay, is there going to be gamma radiation here? I would say yeah, but I don't know how to predict the gamma radiation because the question doesn't tell me. So we ignore the gamma radiation for now. Okay, so that's the first question. Okay, the second question is the uranium isotope decays into, the fifth question. Uranium isotope decays into a stable lead isotope through successive emissions of 8 alpha particles and 6 electrons. Okay, what is the proton number and the nuclear number of the lead isotope? Okay, so let's start with this. This one dia terbalik pula. Now they give us that uranium. Okay, uranium 238 and 92. Okay. After how many? 8 alpha. 8 alpha and 6 electrons. 6 beta. Okay. So we want to know what is the lead isotope. We know that at the end of it is a lead isotope. But I want to know what are the two numbers. Is that what the question wants? Sorry. What is the proton number and the nuclear number? Yeah. Okay. So this is very simple math. Okay. Let's consider if 8 alpha means it's 8 times 4 to billion. Okay. So we want the number to change 32 and 8 times 2 will be 60. Okay. And then since there's 6 beta, 6, 0, -1 electron. So this will be 0 and still be -6. Okay, let's put the original one, 2, 3, 8, and 92. Okay, so this one must minus lah. Okay, so originally it's 2, 3, 8, 92. Minus 32 will give you, sorry, so this will be 2, 0, 6. Okay, 2, 3, 8 minus 32 plus 0 will be 206. Okay, and then this bottom we still need to settle. 92 tolak 16, but we have to plus 6 over here. Okay, because it's minus 6. So 92 minus 16 plus 6, which will give us 82. So this is number. This is our final answer. Okay, 206 and 82. So it's a matter of remembering that kalau electron kan, the number at the bottom must plus. Okay, because electron is minus. Okay, the number at the bottom mesti increase. Manakala kalau helium atom kan, all the numbers will decrease. Okay, decrease by 4 2 because kau kasih keluar kan 4 2, so the original one will decrease by 4 and 2. Whereas electron, since you're taking out the electron, the charge in the proton must increase. Okay, so the proton number needs to increase in this section. Okay, 206 and 82. So let's take a look at this. I think I've given the answers in the. Let's see. You give the answer? Yeah. Okay. So 206 and 82, the number of alpha particles is 6, the number of beta particles is 4. Okay, we're going to look at another 2 more questions and then we're going to call it a day. This is also another famous type of question. Okay, I want you to take a look at the process that they give now. Okay, and a good way to approach this question, sorry, a good way to approach this question is to list down everything that they give. Okay, so the first one, I'm going to use a pen. Okay, so the first one is this one. This is, it starts from here and then end here. Okay, so we find that this is uranium 238 and 92. Okay, uranium 238 and 92. So I'm going to write it on the board. I know you can't see the board, but I'm going to. Okay, 238 and 92. The first decay, okay, the first decay is this first line over here, and then it becomes thorium. TH is for thorium. Thorium 234 and 90. Yeah, I know, forgive my horrendous this one. So first decay, thorium 234 and 90. Okay, now second decay is this second arrow over here. Okay, it becomes PA, whatever PA is. Okay, it becomes PA 234 and 91. Okay, then after that, the third decay is this one. Okay, this arrow over here. So it becomes uranium 234 and 92. And then decays one more time to become thorium 234 and, but this time, sorry, not 234 anymore, 230. 230 and 90. And then the last one is the unknown element, 226 and 88. Okay, so the question is, how many alpha particles and beta particles are emitted during this process? Okay, so let's take a look. Oh, okay, never mind. I'm going to show this. Is this better? No. Okay, so this is the summary of, from the graph just now. Okay, this is the summary of what I did just now. Okay, I wrote down every element. Okay, I followed the numbers at the side and everything. Okay, and everything. So this one takes us very logical. Remember, if it is an alpha particle, atas dan bawah akan berubah. Okay, 4-2. Kalau beta particle, the bottom will be +1. So we look at this. 238 becomes 234 is -4. Definitely alpha particle. Okay, 234 remains as 234 but increase by 1. Okay, so this one will be beta particle. 234 remains 234, increased by 1, beta particle. 234 -4 becomes 230. This one definitely alpha particle. Tak payah fikir sudah. Okay, 230 becomes 226. minus 2 at the bottom. This one also another alpha particle. So according to this, okay, this is 3 alpha particles and 2 beta particles. And that's the answer that we want. Okay, 3 alpha particles and 2 beta particles. Okay, now another way of looking at this is, okay, but this is, there must be a one syarat lah, okay. The syarat is that this must be a nucleon against proton number graph. Okay, if it is a nucleon against proton number graph, then every slanted arrow, okay, is an alpha decay. Manakala every, oh, can I change the color? Oh yes, I can. Okay. Every straight arrow this way, 1 and 2, okay, this is a beta particle. So that's how I get 3 alpha, because if you look at it, there are 3 slanted. Ada 3 yang miring begini. 1, then 2, and then 3. So it's 3 alpha. And then the one that goes to the right, okay, is 1 and 2. So it's just 2 beta. So actually, without even, kita tidak perlu pun sebenarnya, we don't actually even need, we don't actually even need to count all this. Okay, if you just look at the graph, asalkan, as long as you remember that the graph must be a nucleon against proton number graph. Then all the sengit ones will be the alpha, and all the straight ones, okay, every arrow, okay, every arrow will be 1 beta. Okay, please take a look, that there are 2 arrows over here. So that means there's 2, this one. Whereas the alpha is 3 arrows, 1, 2, 3. Okay, so that will tell us that, oh, okay, there's 3 alpha and 2 beta. So there are 2 ways of looking at it. You can do the long way, like I did just now, or you can just take a look at the graph, make sure that it is a nucleon against proton. Okay, and I'm going to stress this, it must be nucleon for this to work. Okay, then you can just straight away do, oh, okay, 3 alpha, because there's 3 alpha, sorry, there are 3 arrows that is sengit macam ni, and then there's 2 beta, okay, because there are 2 that is going to the right in a straight line, okay, or sorry, in a horizontal line. Okay, so that will also be a beta particle. All right? Okay, one last question, I think, then we're done for the day. Now, this diagram shows part of a radioactive decay series. Okay, name the particles or radiations are emitted at part 1, 2, and 3. Now, as I said just now, the method that we talk about only works if over here is a nucleon number. But this one is not nucleon number, guys. This is neutron number. So be very, very careful. Nucleon is proton campur neutron. This is just the neutron numbers. For this case, we have no choice but to do it manually. Okay, so we find that there are 4 elements over there. Okay, we find that there are 4 elements over there. And the first one is polonium. Okay, so this one will be, oh, okay. The first one will be polonium. The only thing that we know is the proton number for polonium at that one is 84. But my question is, what is the nucleon number? It is not 130, people. Okay, 130 is the neutron. So in order for us to know how much is the nucleon number, we have to 130, yeah, 130 plus 84. Okay, 130 plus 84. 130 plus 84 will give us 214. Okay, now first decay. Second decay is from plumbum. Okay, plumbum 82. Okay, so plumbum 82. Let's find out what the nucleon number is. Nucleon number is 128 plus 82. So it's 210. The third one is polonium. Again, okay, but this time polonium, the proton number is the same, but the nucleon number is 126 plus 84. Okay, it will be 210. And then the last one, okay, and then the last one will be Plumber 82 once again, but the nucleon, okay, I'm going to shout this until you get it into your heads. The nucleon number is 206. Okay, we need to deconstruct this into a form that is easier for us to understand. Okay, because the neutron number doesn't help us at all, only the nucleon number helps us. Okay, the nucleon number helps us to figure out what the decays are. Once we have this series, okay, once we have the radioactive decay series, then we can figure out what are the alpha, what are the beta, and if there's I mean, I'm sure there's gamma, but we're not going to include that. We just want to know how many alpha and beta. 214 to 210 is -4. No need to think, definitely alpha. 210, maintain 210, but look at the plus, it's +2, you know. Okay, +2 means 2 beta. 210 to 206, okay, is -4. -4, let's double check, 84 to 82, definitely 1 alpha. So the number of alpha particles is 2, the number of beta particles is also 2. Okay. All right. I think that's all for today. Let me just double check. Because this part I don't go into. Yeah, okay, this part we will do on Wednesday. Okay, so I just wanted to show you a couple of questions that are very commonly asked. Okay, but actually the most commonly asked one is this one and the one before. Okay, look at the difference, guys. The one before is nucleon against proton. Manakala yang lebih tricky ini is neutron against proton. Okay, kalau nucleon against proton number, then you got no problem. Just look at the arrows and they will tell you what kind of decay. But for neutron against proton number, you have to manually do it. Oh, sorry, I'm not showing this. Okay, sorry. For neutron, for neutron against proton number, okay, you have to manually do it. Okay, you have to manually do it as I have shown over here in order for us to know how many decays there are. Okay, so actually that's the class that I wanted to do for today. So I'm going to see if there's any more questions. So the question 182 not. Oh yeah, I think that was the previous question. Okay, Nigel is asking, if you've got question like 5, do we need to write full equation or can shortcut? Let me see which question you're referring to. Question number 5, like this. Oh, no, actually I don't think you need to, if you ask me now, okay, I don't think you need to write full equation. You can write the shortcut. Okay, because actually this question is not even asking for an equation, it's just asking for the proton number and the nucleon number. So you don't have to do this one by one. You can just do shortcut, okay? Apa itu? 8 alpha, 6 electrons, 8 alpha and 6 beta, terus kau dapat the answer. Okay, thank you for the question. It's a good question. All right, are there any more questions? I'm just going to browse once again to see if I missed out any questions. Again, if you are just attending over here, please make sure that if you're from Lokyo, please make sure that you write your name, okay, so that I can click it for my attendance. And if you're from another school, do introduce yourself, okay, tell us your name and which school you're from and which state, so that we can get to know you. Oh, sorry. Okay, double checking, just to see. So far, all I see is attendance, but okay, fine. Okay, I think that's about all. All right, so this last part of my stream, I just want to talk to my students who are under me. Okay, so I'm just going to show you this. Okay, all right, everyone, please take a look. Before our class on Wednesday, I want you to watch these 2 videos. Okay, and if it helps you, please make notes. Okay, please make notes on these 2 videos. This first video is pretty much what we've covered today.
Okay, but this second video will be very useful for us because the second video involves a calculation which is a little bit more complicated. Okay, so please watch this second video in order for you to get a glimpse of what is going to happen on Wednesday. Okay, do it before Wednesday, people. Okay, secondly, I have also included your assignment for this one, okay, which is the 5.1 and 5.2 exercises. But please bear in mind that the 5.2 exercises, not everything you can answer, okay, because we actually haven't finished 5.2. We've only finished one half only lah. So the most of the questions in this section are only on the second half, which is the Wednesday one. But actually, if you have studied this or if you studied this on your own, you can actually start answering this. So I'm putting this up earlier so that you can start answering this if you want. Okay, and I'm about to post up the 5.3. 5.3 is a little bit different. 5.3 is a learning module and exercise. So I'm going to post this up also in the schedule, in the assignment section. But for now, I don't think I will put this as with a deadline. This one other deadline. This one you need to hantar before the 13th of April, okay, which is next Monday. But this 5.3, because it is a learning module, you may need some time to finish it. Okay, so I will post this up in a while, but I want you to take note of this stuff, that you have 2 assignments and 2 videos to watch, okay, for our next class. Okay, the videos is for the next class, but the assignments is to be handed in on the before the 13th. Okay, so if there's nothing else, thanks everyone for coming today, and I will see you all in the next lesson. Bye.